Application of linear functions. We have revenue, that's price times quantity. This is the abbreviation in the formula. R equals price times quantity, P times Q. Cost is fixed cost plus variable cost. Fixed cost would be something like you have to pay the utilities. That doesn't change even though we're going bankrupt. And variable cost is if you're making calculators, well, the more calculators you make, the more it's going to cost. The less calculators, the less it's going to cost. So it varies. In an equation, this will be a number, a constant, and this will have a variable because it varies. Profit is defined as revenue minus cost. What you raked in minus all the things you have to pay off. Whatever you're left with is profit. So minimum, you want to get what you put in. So break even would be the revenue equals the cost. Or profit equals zero. That would be the break even point. Take, for example, a TV that costs $550. The cost to make TVs is described with this equation, the cost equation. Notice this is a variable cost and this is a fixed cost. So this is given. Find the revenue. Well, the revenue is price times quantity. You replace this X with how many TVs? One TV, well, that's 1 times 550. Two TVs, 2 times 550. And that will give you the revenue. Find the profit. So the profit would be profit equals revenue minus cost. So here's the revenue we just found in part A. You plug it in and replace the revenue part. The cost they gave us at the beginning, and you replace it here. Notice I put parentheses because this negative applies to everything goes here. You distribute the negative, collect like terms, combine and collect, and the profit can be described with this. Now, if you tell it how many TVs you sold, like say 5, well, that would be 5 times 300 minus this amount, and that tells you how much profit you'll make. Find the break-even point. Well, that happens when the revenue equals the cost or the profit equals zero. We're going to go ahead and use this version of break-even. So this was the revenue that we found in part A. This is the cost that they gave us up in the top, the given. You set them equal to each other, solve for the X. So this company will break even if they sell 710 TVs. So that tells you they sell less than 710, they're going to bring in a loss. And if they sell above 710, well, that's going to be a profit. This would be the break even. Observation, if we were to draw the revenue and the cost function for this problem, notice what happens. If the revenue is above the cost, notice the revenue line is above the cost, there's a profit taking place. If it's the other way around, if the revenue is under the cost, then we're going to go ahead and bring in a loss. This would be the break even. Supply and demand are also money problems. So supply, demand. Supply is the one that's selling, demand is the one that's buying. If you use a line to describe this, notice that this is the price, P is the price, and Q is the quantity. This is the way they're related. And the equations, the X is the Q and the Y is the P. So notice as the price goes up, the quantity goes up. That means as the price is higher, the one that's selling would like to have more things on the shelf so they could sell at a high price and there will be perhaps a better profit. From the buyer's perspective, the higher the price goes, so here's the price. Notice it's kind of low. They'll sell this, they'll buy this quantity, take this off the shelf. But as the price goes higher, the quantity they take off the shelf is less. Now you want everybody to be happy. So here are the two equations, supply and demand, and we're going to focus on where they meet, where they agree. Where the supply and the demand equations agree, that's where everybody's happy. That's the perfect price for the one that's selling and for the one that's buying. Now notice, if you go below this price, that That means the things become cheaper, right? One person's going to try to take the whole shelf, and there's going to be a shortage. And if you put the price above the equilibrium point, that means the price is too high. Things are going to stay on the shelf, and there's going to be a surplus. The equilibrium point is when supply and demand are equal. Everybody's happy at that point. Here's an example using equations. We're going to find the equilibrium price. So suppose this was the demand equation. This is a supply equation. To find the equilibrium price, you set these equal to each other. Look at the P's are already equal. So you just need to set these two sides equal to each other. So the demand equals the supply. Solve for the Q. This is the quantity, whatever they're selling. Now pick one of the equations. It doesn't matter which one because they are equal. So you could pick whichever one you like. I'll pick the easier one. And I'm going to plug in that Q that I found. I'm going to plug it in here. And I'm going to find that magical price where everybody's happy. So the price is $31.88. So whatever they're selling, if they sell it for $31.88, the supplier will be happy and the buyer will be happy. It's the perfect price, the equilibrium point.